live in a few minutes. Oh, hello. Hello, everybody. Welcome to not Odin Wednesdays anymore, but it is actually Thor Thursdays? Yeah, Thor's show. Odin's Son Thursdays. That's exactly what it is. That's a very catchy title, of course. So, I am now going to just link this out on the, as they call the interwebs. So I need to click the share button and share it to all the different things. All the different channels. Okie dokes. So, all different things are running. Happy going. People are going. I'm going to say hello. Right. We am just getting stuff already. But, yeah. So, inspect. Get the console. Okay. How is everybody? This was completely impromptu. This is me testing out. Well, the word for it is YouTube Live. I have no idea how good this sounds, if I sound good or if there's any sound coming at all through. So please tell me, and I'll try and figure things out as I go along. Hello. Okay, so this is new for me. I've not been on here before. I'm just waiting until people come on. It's kind of a bit new. Hopefully this is working. Voice is fine. YouTube live interface is poop. It is a bit, but yeah, they're telling me I should use a higher bit rate, but it's lower than I've got. I'm like, okay. I'm just going to keep it what I am. I don't really care. It's a bit too much information, to be honest with you, here. Okay, so starting a bit from last night, I did a little bit more, like only 10 more minutes work. I got the emitter to actually emit the entire code that we were doing. This is the add function. So we can actually go through it and explain what goes on. Because I actually understand it now, for the most part. What is the information and what is encoded in that information as well. So effectively, we can go through all of this. So the first thing is, with the new WASM stuff, they have to emit this header. So it's got the magic and the version. Again, these are both just 4 bytes, all in little endian. Everything is in endian. So we've got the header, which is some magic here, some magic thing, and some version. So there's all that wonderful stuff going on. So there's a nice header. So now in each WASM thing, it seems to be there are... I'll make this bigger so you can see the output, because I don't actually care about the rest. This is just all I care about at the moment. Is each of them are split into sections, and each section is pretty much a byte followed by a length of how many bytes are actually for that section. So that is actually measured as a U32, but it can be any length. And then there's different sections. So in this case, we have a type section. We have a function section, an export section, and a code section. So pretty simple. That's all we need. And to explain why this is all we need, this makes sense. So the first one is the type section. This defines a type table. And in fact, it says it's an array of 1. And we're going to emit a function type. It'll have 2 parameters. And these are of those types there, an i32 and i32, and 1 return parameter, which has an i32. So WASM already supports multiple return values, which is actually kind of surprising to me. that it has multiple return values. But it does, somehow. I guess it's just because of its stack-based thingamabobby. That's technical terms. Technical terms. And so there's those things. There is... The next section here is a function interface section, and it says it has 2 bytes. And from what I understand, all this function interface does is, if I remember correctly, it has an array and then it has an index of 0, meaning that there is a function and it's numbered 0. It takes the type of 0, so this is the type it needs to be. So this is the type index for the signature. Okay. We have another section table here. Oh, welcome. What's up? We are working on this WASM assembler from scratch in Odin, because amazing things. Does everything look stream? I've got images on the stream now. I've got my pixelated thing with me having a glass of frothy beer and a Odin logo in the corner and stuff. It's brilliant, absolutely brilliant. I now know how to use OBS. I'm getting technical. Yeah, reasons. So what else we've got on here is there's the export table. Now this export table is pretty simple. So in the export table itself, you have yeah, I think I need to put an indent there, to be honest with you, is that you have a vector of how many different things are going in this thing. So in this case, we have only one, and then it has a name, and then it has different parameters. So this one means function that you're exporting, so it's got named here, a function, and then I think it's the 0th index, which is in here. So that's all it is. Simple enough. And then we have the body of the code, and again, this is the 0th for the code here, the same thing. Simple enough for this function. It's not an import, but it's an export. So it says there's only one in this, and this function's body takes 7 bytes. So we are defining that there are 0 locals, so we can ignore that. But we are getting the parameters, which is get 0, get 1, add them together, and then end. This end, I also think, is the equivalent of a return. I don't think it's... because there is a return instruction, but I think it might not be the same. I think it's just end. There isn't actually a return, is there? There is a return. So maybe I'm just going to try this. Hopefully it will still run, is what I'm hoping. I'm putting 8 there now. Oops, it took it a while then. It's now failed, and it says an expected section length plus 42. So that means... yeah, I didn't require that add for some reason. I just needed an end. Interesting. Interesting, okay. So did my last message go through? Yeah, so yeah, so I'm just seeing stuff on the YouTube chat, so I'm not actually seeing... okay, so I'm not sure what the question was. So did my last message go through? The one link in GitHub thing... I don't see it after I pop out chat window, but other than that, message from Helter for you. I'm seeing the stuff, so I've got them all open here, so don't worry about that. It's all lovely jubbly here, lovely jubbly. Okay, so this is kind of a very simple thing in my opinion. So theoretically, I could make a new add function that doesn't just do add, or it does some more crazy things. Like for instance, it'll take this, and then we're going to add another one, and then add it again here. So that's 1. So we need to make how many bytes? So that was 7. I added 3 more, so that now equals 10. And it's crashed again. Maybe I'm not understanding how any of this works, but probably not. Expected 103 bytes. Yeah, apparently I did. I expect 103 and I didn't give it 103. Okay, so that was crap. Well, I replicated it at least. I think I've been understanding it. Theoretically, just to make this sense, it shouldn't matter which order I do things in, I think. Oh, it does actually. Does it just make... I don't know what's going on. Right, so we are trying to figure out how this all works. So this is, again, me kind of going blind. I don't really know any of WASM before this. So I'm probably making loads of mistakes. So I'm going to get the WASM docs up again. So, and then I'm going to get them on that screen on the right for you so you can see all that wonderful stuff. It's not... That was the awful one. I don't know. Not that one. Not that one. Yes, I'm just replying to someone. Yes, I'm not on Twitch anymore. I'm on YouTube Live, just for a difference. Just to confuse people. That's the fun bit, confusing people. So the docs, yeah, it was the docs on GitHub.io, which was the better ones that I found. They seem to be okay. So here was all the different things here, at least, and had all the different sections. It looks like you do have to pop them in a particular order, which is fine. Not really an issue. I'm just not sure what all the different sections technically mean. Like, you can do a type section, and then in your type section, you can have different function types, but it's only for functions, which is the funny thing. So this type section is not just a type section, it's just for function types and nothing else. So, yeah, okay, fine. I say, I guess you can reuse stuff and then don't. Yeah, I guess it's the whole point. So it's a form of minor compression, but it's a bit stupid. Whatever. So we have the function table section, and all of it is the type ID. Oops. There we go. Okay, so oops. Hello, hello, hello. How are you doing, Andrew? Wonderful. Welcome to the stream. I'm doing some wonderful random crap. Now, I'd normally do this on Twitch, but I don't know how you can stream to two things at once. So, yeah. So that's okie dokes. Now, what else is on this damn thing here that we can take advantage of? Because, yes, if I'm trying to figure out what is going on here. So, okay. I'm just trying to figure out what was wrong with my code section, to be honest with you, not anything else. The data section's simple. Seems very simple, actually, what it is. It's just more data. Then you've got memory index, expression, whatever an expression is, and then the bytes. What's the start section? Start section has an ID8. It decodes into an optional start function that represents the start component of a module. Oh, so it's okay. So it's like the main. You just run 2 instances of OBS and then it's dead easy. Apparently, if that's true, oh no, I doubt it would be work. That's one thing I noticed on OBS is they don't save the keys you put in for when you're doing the streaming. Like you have to put for every platform, you have to put it back in again because that's good user experience. So that's all that's going on here. Yes, this is probably not as popular. Most people have like, what? Wouldn't you be going on Twitch? I'm just trying out YouTube for the time being, seeing if it was working. I don't know if YouTube is better than Twitch or not. So if anyone's got any preferences, please tell me because I have no idea. But yeah, I'm trying to figure out. Okay, so we've got the code section here, and in the code section. Am I misunderstanding something? Yeah, it should be simple enough to go from one to another, because all I'd have to have is 2 windows open to make sure everything's going correctly, is my idea. Now, the only reason I was thinking with YouTube Live originally was because, one, it would save the live chat on the YouTube, as well as save the live chat on the YouTube while just being straight uploaded to YouTube. I know you can do that with Twitch, but it takes time. Okay, so with the code section, it's fine. It decodes into a vector of code. Yeah. That. Oh, I know what's gone wrong. I'm a moron. No wonder I couldn't do what I was expecting. Okay. So I was trying to do this. So this has added 3 more bytes to it. 10. And then because it's added 3 more bytes there, it's going to add it here as well. Sorry, that's where I got confused. So if I build it, run it, it's now doing it correct. So my stack is perfectly fine. So it is a completely stacked-based virtual machine. It's not a register-based, even though I prefer register-based ones, especially infinite register, which are surprisingly easy to make. And all it means is the reason why I prefer infinite register is it assumes that your virtual machine passes through it first and then color codes it and then does what it needs to, because your virtual machine then can take care of multiple more registers, which can be a lot faster. Like I can remember reading papers back in the day showing that, I don't know how much I trust them, to be honest with you, that register-based virtual machines are faster than stat-based ones, which is what my intuition would say, but I don't know if that's necessarily true, if you know what I mean. Yeah, so that's the case. So at least we are now figuring this out. Now, this hand-based emitter is clearly not a great idea. So what we do want is an emitter, effectively, per... what's the word? Yeah. We want an emitter for different sections. So, for instance, effectively, I want to add a function, and that's what it is. So in that function, I set everything up. Now, if there's any WASM experts in the audience, please say, like for instance, how would I encode a data type such as like a structure? Or do I have to completely do it as a binary memory? Because it seems like it has the built-in types, which is the 32-bit integer, 64-bit, and the floats, of course. Have result types, which is the function types. We have limits, which I'm not sure what the limits are. Is that for something else? I'm not actually sure what that means. And then memory types. Memory types are encoded with their limits. Okay. Table types. What the heck is a table type? So memory type, table type, and global types. Whatever, I don't care about the global types. So memory types classify linear memories and their size range. Limits constrain the minimum and optionally maximum size of memory. Okay, because I guess it means you can have an infinite growing table and just keep appending. So yeah, it's not a bad idea of doing an arena. So it's not that bad. Type table. Like memories, tables constrained by their minimum and optional maximum these limits are given in number of entries. The element type funcref is the infinite union of all function types. A table of that type thus contains references to functions of heterogeneous type. Is anybody understanding any of this? Because I really am not. It's a bit of yeah, making sense? So no. Okay. Because the reason why I'm asking is mainly just because clearly this allows you to have multiple return values. Well, I say clearly. Because what I could do here is say 2. So now it means I've got one more byte to worry about. So that needs to be 8. Right, so I'm just checking this out because theoretically I got 1, 2, 9, 11, and then it's failed. Alright, so this is stupid. Who designed this flipping system? Because if your bytecode tells you how many it's 1 or 0, then you would expect if it's... Oh, you could want multiple, but it's saying you're not allowed to have more than 2. Well, that's just plain stupid. Okay, so I can do that, and it does the adding. And it is adding correctly, because it is in the... I don't know... I can't remember what I added to actually make... Oops. I call the instance exports. No. Like, I've got this async run. Actually, I shouldn't have done that because I generated every time. So the question is, yeah. It's designed by people who have never touched actual assembly. Yeah, it looks like that might be the case. Yeah, it is appearing to be that people have not actually done this before. It doesn't surprise me, it's web people. Really, like, not at all surprises me at all. So I'm going to do this. So that means now I've got instance exports add. So, and it's an anonymous. How is it anonymous? Why is that anonymous? It's not defined apparently, but this is in... Okay, now we've got some more JavaScript questions. So how do I add a variable to the global scope? So I can access it here and not have to worry about it. Like, I guess this is not actually a global variable. I guess you want to define it with the window. Is what I'm just thinking now. Actually, that was actually a clever idea, Bill. Oh, why didn't I think of that before? Build that again. Repeat. Window instant exports add. 2. Oh, look at that. Oh, look at that. This is amazing. So just to prove that this is amazing, we're going to go back into a bytecode. Well, we've got add. No. That's boring. Let's multiply this time, but we're calling it add still. We're going to call it... Actually, no. You know what? We're going to have 2 functions. Yeah, one's going to be called multiply. And it's going to have the same function signature as the other one, so we don't have to change it. Like so. But now we need to increase the amount of bytes. In fact, yeah, let's just, oops, daisy. Can I emit bytes? Do I use bit bytes anywhere? No. Yeah, let's just do that, because then I can go... like so. They've got the same signature now. Oh, ho, ho, this is getting good. This is getting good. So we now have 1. It's 7 originally, wasn't it? So, and then I've doubled it up minus 1, so it's 6. So it's 6. So it's add 6 to 7 is 13. Yeah. It's still running. Perfect. So now we've gone to 2. And then we're going to emit another 7. So this is going to be add. And that's going to be multiply. And we're going to put the multiply instruction in there. Now we've added an extra 7 bytes. Actually, no, we haven't added an extra 7 bytes. We've added an extra 1, 2, 3, 4, 5, 6, 7, 8. So this needs to go up to 17, right? No. Did I do that wrong? 9. 8. That should be correct, right, guys? Yeah, I'm just setting it differently, so I'm just doing it on the Windows. Do it from the console. I'm just cheating with JavaScript. It's coming back to me compared to last night. That was just really bad. Worse than I've ever programmed JavaScript. Like, I forget most of it. If I don't keep up with it, I don't remember all the conventions. It's not like the language itself I forget. It's just the libraries and the functions, which, again, most people don't separate, but I do, so it's, yeah. Thank you, Ben. So what you got to say, I've got 2, and it's still got the type index for the signature. Thank you, and that didn't work. No, it's 3. Aha! So, we have add, and wait. We got, that's not multiply. That wasn't multiply. Yeah, I thought it was 17. Look, so the next thing that we're going to do tonight is pretty much make a make function, and it will just add up this table, and then we generate from the table to the thing. So why is that? Or is it do it because I have to do 1? Like, I can't, I'm trying, no. What's that? Is it 1? Because I think this is it, and then you have to do the add. Multiply, there we go. So I was correct. Okay, so I was wrong. So this is saying it's a function. And then you have the index. So it looks in which function you have to do. So, okay, so we are getting it correct. So we have now kind of got most of this working. We have now got the emitter type as well. In our emitter, though, we can now specify... I'm trying to think of the best way of describing this. So before I do anything, with these emitters, you have to express a type. Now, my question I've been asking is, I can clearly do the basic value types, which are integers and floats. But I guess I can't do pointers, obviously, so a pointer would just be an integer, and you'd have to know what was a pointer, or obviously, which is, again, what a pointer is. It's just an integer at the end of the day. So that's fine. But could you pass... can you pass like structs to it? Or can you only pass those basic types to procedures, functions, whatever you want to call them? So we're going to create a function. So, I think I know what to do now. Here's the emitter. We don't need to add in the emitter stuff, but we do want to add call it a function. So it's a WASM function. We've got to give it a name. So obviously it's got a name. It's got a signature, which we're going to call signature. And then we're going to have different parameters to it. So have parameters. And I'm just going to... Well, no, I'm going to keep it as slice just for the time being. I don't really care about types. Val type. And results. Like so. Now, results could be blank or a 1, so I'm going to be stupid. I'm going to make some maximum values up like this. No, param, len, result, len as well. And I'll make them a U8 because I think the value type is a U8 as well. And I don't want to waste too much space in my struct header. Okay. And we know we can only have one maximum. Okay, so we've got signature here. And we want to have it to be a pointer, because then we can reuse them, of course, like intern them, all that crap. Yeah, so so they're saying for structs you need to know that. So that's where my question comes in, is I'm looking at the instructions themselves, and I don't really see any instructions that help you there. Maybe I'm missing what the instructions are, because you have unreachable and no op, they're fine. We have a block, loop, if, end, branch, branch, if, branch table. Is branch table the one I was looking for? Actually, that's wrong. That's meant to be an E. Call, indirect, drop, select, and all the other crap. All the other operations I've just done here. So I'm just putting all those in just so I don't... I'll fill them out in a minute. Yeah. And one more there just for sanity's sake. Whoops. Like so. I got a gap here to make sure that I can check for these. And I don't know if I put them in correctly. I think I should have them actually that way around, because it's little endian. So little endian means you'll encode this and then that. Yeah. I think. Yeah, we'll find out. We'll look at the instructions later. So we need to create a generator for the function. So we have the name. We have the signature. Is export. Yeah, most of them are going to be exported. Don't see any reason why not. What else do we have in here? And then we actually have the code. Yeah, so we have code. And that's going to be a dynamic byte. Just going to be code, and you're writing the code as you go along. But you can also have locals. So these locals... I'm not sure how many I won't do any locals for the time being. But that... So we'll just keep the signature blank as well, just be lazy. Let's just limit it to 8 for the time being. It doesn't make a difference. Just limit minute minor things. That looks okay. I think. Okay, so that sounds like a good idea to me. Maybe. Let's call this functions, and now we have a function in there. So in our emitter, we can add a function. Yeah? We can also just have an emit function. Emitter. No, let's emit functions, because then we can go through each of them and add them up, can't we? So no real issues there. Make sense? Be lazy about it. And then it's effectively all of this. Because all that type table there, all of this effectively, except for the exports, we're just going to treat it as if that. But no, it's not do the function yet. I'm trying to think how to do this. Actually, that's all I'm thinking. So, function. Let's call this func add. Name is add. I've already forgot what the actual function says. Signature. You know what? Let's bring it down here because this is huge and I can't have two open at the same time because otherwise people on stream won't be able to see what's going on. That's my problem. Let's add signature on the other hand. We are going to add some parameters. It's going to be 1. Oops, daisy. Param length. Now, technically, I don't need the param length because I could determine it from this. But results like that. And then we've got param length of 1. Now, theoretically, because they know these RU types aren't ever going to be 0 if they're not a type, we can actually generate it from that. So if that's the case, it's null termination, chaps. Actually, that's not a bad idea. Why didn't I think of that? It's probably a bad idea in the actual long run, but no, I should just screw it. Screw it. Let's just do it like that. Yeah, keep it correct. So there's the signature. Is export is true. And then we haven't got the code. So the code, all these emitters technically take the binary data for the emitter. So which is annoying, but yeah, that's annoying. I shouldn't have done that. Damn. So all these emitters. No. Let's keep it. I've got an idea. So go back to the function. Emitter. Have your own emitter in each function effectively. So then you have all the functions here. Yeah, let's just do that. And then we can have a function multiply as well. By the way, this is a new feature I added into Odin recently, which is to make it feel like C99 with its stuff. Makes any sense. So we can add different functions as we're going along. We can then go for each func in functions. We can then do this. We know how much data we'd need to do for it all. So byte length. Sorry, this is just me trying to figure out the length in bytes. Something has to be. To do actually calculations. So if I do that, that's fine. So the idea I was having here is different bits. So type bytes. Yeah, and we got this length of how many bytes you actually need to require. Yeah. Oh, no, no. So that is... Can you see the problem here? Because you're actually having to do it backwards. So it's not actually an issue. It's just you need to go through each function. So this is for the type table. So this would be type section. Bytes, byte length, like so. So we know how many are there. And we know there are... Well, actually, ooh. Wrong way around. Yeah, I'm doing that the complete wrong way around then. We know there are that many functions, so we need to add that to the byte length. We now know there are... Each is a function type, so we need at least a byte. Then we need to go through each func. This is probably... Okay, if you've got any questions, please ask away. No problem here. So we now know if there are different things going on, right? So I think you do need to specify the length of the next stuff, even if it's 0. So we need to know the results, the inputs. You think byte length int of the function parameter length, and then you need to go for I in naught parameter length add 1. Actually, no, all you need to do there is that. Is that correct? Yeah, that's correct. And then we do the same thing here for the result length. Yeah? Because each is a byte. So if that's the correct way of looking at it, we can now go and emit that section. So we can emit that section of the byte length. And that was taking a U32, wasn't it? I think everything should just be U32 in this case, so we don't need to do anything special. Like so. So we now emit the byte length. We now emit a vector, which is the length of the amount of functions, and now we go through each function like so, and then emit another U32 of the parameter length, then for I in the parameter length, emit type, which is going to be the func parameters like so. And you can do the same with the results. Result like that. And then theoretically, this should work. Oops. Result length. Signature. Actually, what I need to do there is actually, because I was doing that, it's probably a good idea that I put using there. because it does make more sense to do so. And I didn't need an emitter on any of them. No, I did for the code. Yeah, making sense so far? I hope so. I hope, at least. So there's that. So to prove that they are the same, build and run. It's going to fail. Now that's a good question as to why that is the case. I'm going to do this. Look at what is being printed for that. Compare it to what is being printed. Should we just get rid of the header? They are not the same. Interesting. So I've probably counted up the total amount of bytes wrong, haven't I? How have I done that? Right or wrong? Or is it just one off? No, it looks all wrong. It looks completely wrong. So the bottom one is the correct one. The top one is the wrong one, obviously. So what am I doing wrong? I'm not calculating it correctly, obviously. This should be 7, and it's actually being set as a bigger number. I got a +1 there for some reason. We've got the length. And then for each function, we're doing each parameter. So it's the parameter length and then the length of actually the parameters, the result length and the actual result, which looks correct to me. And then we omit it. So that looks, the mathematics looks there correct. Now get rid of one. But no, it's wrong. So what is going wrong? Let's figure it out, Bill. The byte length, section size. But that isn't the section size, is it? So what is going wrong? Let's figure it out, go through. So that's 1 byte, 2, 3, 4, 5, 6, 7. Yeah. So 1. Yeah. Now we've got 2 functions in the array. In those functions, just for sanity's sake there, in those functions we have we have to set the first bit, which is the amount. Great. And then we have one for the func type. Yeah. We then have a vector here. Vec count, and this is param. This is result vec count. That's the parameters, and that's the results. So what have I gone wrong in my logic? What's gone wrong? We have the byte length, which takes in the number of parameters, and the parameter length, result length, and none of that section size gets adjusted. So I need to assert that the section size equals 7, which it doesn't. We know it equals 13. So what's going wrong? Seriously, I don't understand what's going wrong here. Let's look at the functions. Let's just add on. Let's do that. It might be a bug in my code. No, it's not, but let's do the length of the function. I don't even know what's going wrong. There's two functions in the length. Yeah. Okay. So the first function and the second function. Multiply, yeah, they've got all the right data. Got the right results. Everything else. Just adding that in for sanity's sake. They're both exported, yeah. But what the heck is going on here? This makes no sense whatsoever. Like, I don't understand what's going on. Okay. What the heck is going on? Okay, so it's probably obvious, and I'm just not thinking straight because it's tired and drunk. Not drunk yet. Yet. So to me, I'm guessing the logic is wrong here somewhere. Like, yeah, the logic is obviously wrong somewhere along this route. Now it's 9, so it's even bigger. So the problem here is this param length. What is the loop? I'm looping around the function each time. Interesting. Maybe this function's wrong entirely, like the byte length is wrong. It's like not the actual logic. That wouldn't surprise me actually if that was the case. 2. 1. So 1, 1, 2. What? What? Oh no, it's not wrong. What am I doing? It's absolutely correct. Because I only actually do it once, don't I? I only actually have one function, so there's only one function in the type table. Yeah, oh my god, I'm a moron. So my code was wrong. I was like, what was wrong with my code? No, nothing was wrong with my code. In fact, everything was correct about it. Oh, you idiot, Bill. Okay, so we now know we can remove this. Yeah? And if we do that, it fails because it's not got the header anymore. And it's expected type form got O2. Ooh. Ooh. Yes, of course, of course. Mit type. Function type on every little thing, and then it works out correctly. So now we've got this section table and we're actually generating it correctly. Now we do the function section. Yeah. So the function section, we need to do the exact same thing again, but this time it's an index to the function signature. Okay, so all we need to do is the byte size. So we need to figure out the length of the amount of functions. And then we need to go through pretty much just that, to be honest with you, for the functions, and go through the logic of that. Makes perfect sense to me. So now we can emit this section size, emit a U32 of the length of the functions, and then for each function we can just give it the index. Doesn't matter how wasteful it is for the time being, we're not doing interning of the signature types, and it's working correctly. So we can now do the export section, and we want the section size again. But this time it's a little bit more complicated. So what you need to do is give it the index and the length. So we need to know the length, yeah, and then for each function we need to give it the length of the name, and actually the length of the name itself, because you've got to put the data in there. You've got to put 1 on the end, and then you've got to put the index. So that's now the section size, but only if f is export or not export to continue. So we only want to do it if the function is continued. So we need to actually function count, no, exported count is not actually taken into account yet. So we do that right at the end. So it doesn't matter about the order. There's no padding involved. Yeah, so we do that. So now we can export size, emit a U32 of the exported count, and then go through each function. If it's not exported, ignore it. We can now do the emit name, and whatever that name is, emit a byte, and then that byte is going to be just blank, that means func, and then we're going to emit a U32 for the index of that function. Yeah? Okay, so that should have actually done it, and it is doing it. This is actually looking a hell of a lot more generic now. It's lovely. We don't have to write it out by scratch. Now we need to do is each bit of code. Now this is where things are going to get a little bit more complicated, because you need to figure out the amount of bytes per thing. So that's actually not complicated. That's really simple, actually, thinking about it. Yeah. So now this is the code section. So each code section is going to be fine. So we already know that we need to have ubyte length len of functions, so we need to take that into account. And then for each function we need to U32 it, the byte length, the len of the functions. Yeah, so one thing I notice here, every single parameter I'm passing to it is being casted. Every single one. That's a little bit silly, but that's easy to know, that's easy to fix. Clearly you didn't know what was needed, so it just doesn't matter. Then we need to add the len of the function. Oh no, I mean len of the code. But no, this is an emitter, so we need the binary data. And that should be enough for the code section. Section size, emit an EU32, which is the len of the functions. And then for each function, we want to do this. So I'm just going to copy and paste that now for the time being, because theoretically, it should be identical. Yeah, theoretically, it should be identical, but it isn't, because it's probably wrong. So let's undo all that, just so I can have this and redo. So we know it should be 17. Just make sure section size equals 17. We know it doesn't. I just realized why. Because we don't actually have any binary data in there. And everything should be correct now. If they're enjoying this still, is it still making sense to people? What's going on? What I'm doing for this basic assembler? It's very, very simple. You pretty much just generate the functions beforehand, turn everything in your function tables, because that's what you're doing with your assembler. Is you set up all the tables, and then you just generate it by writing it out. So we're working our way backwards, which is quite, I don't necessarily if it's the correct way of doing things, but it's working from very bottom up. We have the assembler written already, technically, and then we're just building a generic assembler, so we can make a generic language, make an assembly language in that sense. And then from that assembly language, we can then start making a new higher level language, which is the whole point of this kind of thing I wanted in the first place. So for each little function here, we can add our own little emitters. In fact, again, each function can just be a pointer already. So what I'm going to do here is that once I've added every single function, I'm going to go through each of it and go through each function add code, because each is now the emitter. It is overshadowing it there. Whoops. So it's not overshadow it. And then we've got another one here. Function, yeah, multiply dot code. Code. So now that we've got that, we can actually, again, build it. And then we can go through each function. So each f in functions, we can then just go emit bytes and be just as dumb as anything. Emit code binary data. And now we've got a bug, because not everything is expected as you would expect. Expected 17 bytes, fell off at end. So what was going wrong here? So we've expected 17 bytes. We didn't get it. So we can just test this by going emitter binary data len n1 n0 print in line of n1 minus n0. I'm going to get rid of this debug print for the time being. 15. So we're missing out some data. Yes, of course we're missing out data, because we need to emit the length of that data. Yeah, that is exactly what we were missing. Perfecto. So, hey presto guys, everyone, we've now got our own little code emitting thing every time as well. That was relatively simple. We're not done any As you noticed here, we are not doing anything special with the stuff. So each of these, we could probably give it an index as well. And we could give the signature an index as well. Just give it, because we haven't done it yet, but we can do it. Because that means we can then do whatever. So we're not going to call that signature, I'm just going to call that sig, just to make things a little bit easier when I'm doing this. Sig, 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 and now it's all working correctly. Again, if you've got any questions, guys, just ask them. I'm absolutely fine. We're doing pretty well now. So theoretically, we can now add our own stuff and be more generic about it. So I can now add another function to this entire list, and I'm going to call this foo. I'm going to do the same sort of operation here. Yeah? Keeping it simple. But this foo operation does a little bit more complicated. We've got no locals. So we say no locals, and then all we're going to do is going to get the first two parameters. Like, so we get the first parameter. We're going to do multiply the. We're going to do. We could do Fibonacci technically, couldn't we? That's the thing. You could do Fibonacci. That's not a bad idea. That really isn't a bad idea. Thinking about it, no. But let's not do that yet. Let's just think of a simple calculation. Let's do not Pythagoras, but we square each number and add it together. Make sense? Yeah. Yeah, so I think the way you do that is you square each number, you multiply it. That won't work. I know it won't because it's going to crash. Told you it was going to crash. Because I don't think I've actually taken into account correctly. And it's going to say compiling function number 1 failed, trailing code after function end. Yeah, because there is this here, which is not, and it's now doing it correctly. So if I do instance foo, and I do 1, 2, I should get 5. So 1 times 2 is, yeah. 3 by 4 is 5, yeah. So it's working out as I expected. This is just a stack allocate. This is a stack VM, so if you've used them before, you can see how the logic works. They're quite simple. Because you're just pushing them onto the stack. Yeah? Sounds as simple as very simple, but that's the case. So we can start working with this now. In fact, what I would recommend is we can create a function. We don't have to keep doing this silly thing here. Yeah, we're going to create a function. Functions. Definition. And then once you've got a definition, you can actually just don't worry about any of the crap anymore, can you? Yes, so everything is working, and we have got things working here. That is, I'm honestly, that's quite good. Yeah, so that's working as I expected, which is saying more than I was expecting, to be honest with you. So we've got to create a function here. Yeah. So for this, functions like so. And then we don't need the function data necessarily, we just need the code actually, come to think about it. So we need to remit emitter. So if we do create a function like this, we can then have the code. And in each block, we can just do that. So now we don't have to worry about the names when we're dealing with it. Now that, in my opinion, is kind of reduced some of the possible bugs I was getting. We're not create function, so it's adding in out of the function table, and so on and so forth. So now it's going to tell me some bugs, but that's fine. Perfecto. Everything is working as I expect. So this is actually pretty damn cool. If you can tell, this is pretty damn cool. So for people who don't know what I'm doing, so what I'm building is a WASM emitter in Odin. But the reason why is because I actually want to make my own little language that outputs to WASM, because I want to make something that I can do for the web, which means I don't actually have to touch JavaScript or HTML or CSS ever again. I effectively want to make my own proper language for the web, because if WASM allows me to do that, this is great. Because they shouldn't be separate things. Again, I should be able to make my own language. I should be able to make my own tech or LaTeX or LaTeX. I don't pronounce that word correctly, but or make your own PostScript or make your own whatever, because clearly it should be possible. So this is my own idea, and my idea is that it's not going to. I wasn't going to use Odin and emit to WASM for Odin, because I think the problem is that WASM itself is a very specialized instruction set for this virtual machine. So rather than trying to fit a C-style language to it, why don't you actually design a language around the instruction set? It may look like Odin, or may have very similarities to Odin, of course, but it'll be very different at the end of the day. Yeah. So we've got all this going on here. Now we've got the actual code generation. Like so. Now these functions on the emitters are slightly different. I've got an emitter here, which is I'm just building up whatever. I'm just keeping it like that, dumb. This is going to be... I'm trying to think of a name for a struct. Contains all the information to it. So yeah, so the harder part will be dealing with the rest of the browser, so you can put stuff on the canvas. You're right. So that is something I've already been considering. Is I'm looking like I'm going to have to create a function table in JavaScript already, which I generate, which then you pass to your application, which is built in like its main function, pretty much its own startup function, which you pass to everything. And then that's how your application gets ran. So you have the environment, the minimal environment in standard HTML and JavaScript and CSS, whatever. But then after that, you never touch it ever again. You just have the canvas and be done. You have everything else like done. You don't even need a DOM, because I think you could probably just get away from that yourself if you just have a canvas. Does this sound sane, or does this sound insane? I know it's not a small project, but it's a nice little one. Especially on like little streams like this. Yeah, makes sense. Hopefully. That's what I was looking for, the word assembler. In fact, let's call these funcs for the time being. There's no real difference. And then we can have create function. From here, we can then have E for emitter. So in each function we have ASM for the assembler. Can't have ASM because that's a keyword, because I know why. Just call it A. A dot funcs. The definition, we just copy across and be done, and now we've got a new emitter for each function. So assembler, like so. We can get the references on there. So apparently it sounds sane enough, but the browser API is still annoying and requires a lot of bunch glue and JavaScript glue. I understand that. But there are things in the works to mitigate this eventually, yeah. So the idea, it should be, again, I think it should be doable. Like technically you just need to provide your own runtime library in JavaScript is effectively what you need to do. Because you need a minimal runtime library for this. But saying that, that should be all you need. Like I don't see any reason why, maybe I'm wrong, reason why you would need to do this. So generate assembly. So we want to do that. Now we do this here. Yeah, I know I did wrong there. What I was doing wrong there was effectively this. So I wanted the last one, effectively. So then I've got the funcs here. Functions are not there, so they're under funcs. E is got binary data, but it isn't. No, it is defined. It's in the assembler emitter. Okay. Everything is still working. But look how bloody much nicer that is now. And we have just writing the functions as if they were effectively normal code. Which now means, for the most part, we can deal with this normally. Again, with these parameters, we could actually figure out the parameter length automagically by not even passing them. So when we go to the function every single time, and we create a function like this. We go, we'll call this func, like that. And then what we can do is go through the signature for the time being. We're just making duplicates every time. We don't really care about memory size at the moment. Is for param in func.sig.params. If param doesn't equal void, then func.sig.param length adds 1. Else we break. Yeah? So another way of writing that is we break if it's void and do the rest otherwise. Result, we do the same. So now this is pretty much a C style dealing with crap. Yeah? But I think that would probably make it simpler when I'm writing crap, anything like that as well. If it makes sense. That seems nicer to me, actually. So, let's carry on. Let's see if we can go a little bit more complicated with our stuff. So anyone got any ideas? Because effectively what you're writing here is still a instruction-based thing. So here's one expression. That's one expression. That's another expression. And this takes in two expressions. So this is why like the WAT expressions, we're doing this, and you could pretty much write it, call it local get naught, local get naught, and you're effectively writing it like this, and then it's in, is it reverse or forward? I can never remember. Multiply I32, and then you could write another one again in S expressions of add I32. Yeah. So effectively, this is what your code is looking like. Is that reverse or forward? I don't remember ever, whichever is which. So effectively, that's what you're doing to it. So you've got, here's one instruction, and then it takes two arguments, and it goes to it. And that's what you're doing with this function. So if you can build it up as if it was like an S expression, reverse S expression, of course, but still an S expression, then that's how this stack-based thing works. I'm just trying to explain it to people who've never actually done a stack-based VM thing before. Because a lot of this may be new to a lot of people here. I don't know people's background, obviously. Okie dokes. So, let's do some complicated calculations. So theoretically, because I now know the different functions, that's good. So when we when we create a function, so create a function, function, oops, lookup, that's a map to a string and an int, yeah? Now we want the default to be -1, but not, that's the problem, is we don't do that yet. So just default 0 is wrong technically. So yeah, let's just leave that for the time being. I think I've got an idea. Yeah, so func, we're going to call this the func index, of course. We don't need to store it on there yet, we can just store it here. There's no point storing it to ourselves, we can just put it on the func name, and then the index is going to be just the actual index of the thing itself. So that's okay, and that's on the assembler. So we could theoretically call the add function and get its return and do these things. So we could do emit op call, and then we need to call once we've done. So what I'm going to do to make this, it's just simpler for myself, make it 2 for the time being, put the main back on here, get rid of this thing which was me to understand the code, because I understand it now properly. Actually, let's not get rid of that, let's just copy that out. Is we want to know what the call instruction does. So we need to check on the modules and then look at the instructions, and we want to look for the call instruction, and then it's a function index. So I was correct. We want emit call code, and then we have the function. So I'm just going to call multiply. But we want to also pass the assembler to this mix. So what we can do here is function, it's a func index assembler mul. So that's, we can do wherever all the emitters are here. Yep. So emit call using emitter, and then we want the index. Okay. But we want the func index as well for the assembler and the name. And what I'm going to do is we get the index OK assembler func name, the func lookup name, assert OK, and then return the index, because we don't want it to do crap. So theoretically, if this works correctly, which it should, I don't see any reason why not, we can replace these things here with a multiply. That one, both of these with a multiply, and that with an add. Oops, and that should be a U32. So it built correctly here, but that's doesn't mean it's correct here, but it is failed. So that's because I just want to make sure that it's these. Emit op code multiply I32. That's an add 32. That failed as well. Ooh, what's gone wrong here? Let's undo all that code. And now it's failing still. Ooh. That's really weird. Is it because I did all that nonsense there? And I might just... You know what? That was probably a bad idea. Just thinking about it was probably a bad idea. Let's just do it again. I cocked up again. Param length equals 2. Result length. I'm just going to do this all again now. Yes, I'm that clever of me. Not. Param length equals 2. Result length equals 1. Okay, so that's all correct now. We go back to the assembler and then func indices. So we go back to the string and then we have an index for the func indices. A.if func indices func name equals that index. Yeah? So then when we go to do an emit call using an emitter, we can then do the func index and do it correctly. So emit that's called, is it func index anyway? And then we can emit the operator for the call. Now, before we do any of that, we can do this. So one thing I wanted to do extra as well before we do any of this is just make sure that lengths of the sizes were correct. Func param length equals 0, but func param 0 doesn't equal void. Then what we're going to do, actually no, it's just I don't know how to label this API at the moment. I'm just going to pretend I know what I'm doing, which is going to be good. So first we're going to just try do an emit U32, and we're going to call index 1. Hopefully that should work, and it does work. So if I now do an emit call, actually no, wait, emit call, we don't need that yet, we need a so we need to get the index OK a dot func indices name. I'm going to assert OK and then return the index. And I'm doing that on purpose for the plain reason it should work. So now we've got this a thing here, emit call code func index, which is the assembler, and then from the assembler we want to pass in the mul name. So we can now have it working. Look how good that is getting. Seriously, that is actually pretty damn cool. And then we can do an add. Oh, look how good that is. That is hunky-dory. In my opinion, absolutely hunky-dory. That is wonderful. So the reason why I'm saying that is mainly for the plain reason that we can start getting this thing correct. Yeah, that makes more sense. So we can probably, what's the word for you? We can probably intern those signatures eventually, and I can make it in a much better fashion as well. I can think of a much better way to create those signatures every time, and then don't worry about them. But for the time being, let's keep them dumb, and don't worry about anything special. Let's just keep them dumb and do it that way. Okay, so that's the cool thing, and I'm really surprised this all works. We can get rid of these stupid calls, but at least we know the calls work. So, but the thing is, you'd have to create the functions before you get so we need to get the func. Function that. We need to get that. Then we get the funcs. We get the index, and then we get the func. Because we can create as many functions as we want pre-hand, and then we can get the code afterwards, which is not a problem. So that, to me, is actually a pretty good little assembler so far. This may not be how everyone else designs their assemblers, but it works for me. Just emitted ball, literally stupidly. So what else could we do? What are some complicated? So we have square roots. We could do it. This foo could be the hypotenuse, which is what I was going to do originally, which is the square root. But so what I need to do is I'm going to get rid of these stupid calls. Emit op code multiply I32, multiply I32, add I32, and then I want to do a conversion from I32 to F32. These are the wrong name, these are truncations, but I need to go convert. I'm just renaming them. Because actually, look, all these 2 ones, this is where it's probably confused me as well. Like, I'll undo all of that. Because they weren't originally called, they didn't have a 2 in there. They didn't actually do anything like that. They actually were called, if I can remember correctly, this. Like, they all were like that. And they had the actual type at the beginning. Now, I didn't particularly like that style, even though that matches the thing correctly. It's because it wasn't very... It told you what the type that you required, and then it converted it to whatever it needed to. So just keeping it the same for the time being, that's fine. So I need to go from that and convert to that. Yeah, I'm going to assume it is signed. This is where the I32 bit is a bit crap. You effectively need to put U32. But is that correct? Have I done that wrong? So what is the converts? Am I missing something here? Am I? I don't know. Any help? No? No? Yeah, yes? Yes? No? Anybody? No? Yes? No? No? Maybe? So people enjoying the stream so far. It's been going on for about 90 minutes now. Questions. Do you prefer this YouTube live to Twitch? I don't know. The interface for YouTube live is a little bit crap, but it seems to have the live chat saved at least. So I don't know if it's any better. I've some people on the Discord are telling me just Twitch is better in general, so they're probably correct. Ooh. I just want to convert. Okay, so this is where it gets confused. It's confusing. Yeah, so what I want not the truncation, but I do want the conversion. It's the wrong way around. So you want the convert from that. Then as another opcode, you want to do the square root, and it's the F32 square root is what I want. Like so. So theoretically, it's going to crash. This is my idea. You add them together, you do a conversion, then you do the square root. Now, the reason why it's going to do that is because I need to go back and convert it to an int, because it's the wrong type, of course. But, so now it's... Yeah. That is not at all confusing. Yes, it is very confusing. So if this is correct, 3 and 4 should make 5. Yeah. This is Pythagoras now. Great. So what is it? 5 and 12 should make 13. Yeah. That was actually pretty damn good. So what we have done today is actually created our own little assembler. I'm actually kind of proud of this in a sense, because I can think easily how you could generate this to work. Now the problem is, what you would need to do is effectively, so the problem here is not necessarily, how would I do this to make it actually make a language? Because you couldn't make it single pass as well. Well, you could make it single pass, but you wouldn't want to. So, like this is, I'm not joking, this is pretty clever. It works well. I can now say, actually, let's not do that per se. Let's make all these F32s. So then we can get rid of, like so. Look at that, guys, look at that. So a lot of these is pretty okay, but it's just those names. Those names are so bad. Like, seriously, like, it's really annoying me what they do. For instance, we have different names on these things here with a signed division, non-signed divisions, whatever. So in these cases, I think I'm just going to call them I32, U32, I32, U32. Now, let's call them S32s, just to make it very clear that it's a signed thing. And they got rotten off. Okay, so for saying people who have written this are probably never done an assembly language, and they've clearly just done a virtual machine for whatever reason, whatever. They've done a stack-based one, whatever we care. At least they've put bloody rotate. Oh, rotate as instructions. Thank you. So they did know some sense. Only some sense, not much, but they've got some. Okay. Okay, so by the looks of it, it's going to return that value is the name. The first parameter type here is its return. Yeah. So I understand why they've done that, and that does make sense from an assembly standpoint, actually. But it's just conventions. It's not clear to me. Why? So I'm just going to do this. Like that. And I'm just trying to make sure the things are named in a way that at least makes sense to me. Like, the signer should be on the type, like that. And then the rest is fine. Okay. Yeah, I understand what it's trying to imply. It's trying to be like a method in that regard. It is kind of like, this is the method of this type that can do that. I think maybe that's how with the dot it makes it kind of think that way. But to me, I just want to call it an instruction that's got a decent name to it. Right, these saturation ones again they take up 2 bytes of instruction. So we're going through these again. And we could do that. Load I32 as that. Yeah. Store 8. Okay, I think I'm happier now with those names. Actually, are much better names. The reason why I'm saying thinking of it as a method is I'm just thinking it's like a web people, or maybe they're doing like a method. I'm probably wrong in that regard. It is probably just an instruction, and they're just saying, look, this is a return value, this is the name of the function, and we've got generic names for all of them. That's all. But seeing it as a method kind of does make some sense. I'm just trying to... but for me, this now makes much more sense. Like, convert a signed 32-bit number to a F34 and do all them. Like, that makes so much more sense reading it. Let's call that hype. So foo won't be existing anymore. But hype is. Just again, we've got the basic triangles. And then 1, 2, 3, 5, 5, 12. Ooh. Yeah, and 3, 4. Perfect. So they are all working correctly. I am pretty happy with that. Let's sort of just do that crap. I'm actually pretty happy with this so far, because this is working as I'd expect. Again, is in an S expression stance, where you push the expressions, then push the instruction. So yeah, we could figure this out technically, and we could make our own emitter stuff, and you could easily do it a different way. But next, I think after done this, and we now have some basic functions, we could probably start designing a language. Not right. We could do it now, but I don't. Probably not. Oh, these extend names actually. So, ideas next. So we've got to, if we were to design this language, what I'm thinking of is, this is actually a complicated thing. So probably it's not the best idea to start with the language yet, because I need to think about what type of language I want to design. So this could easily go toward like a C-like language for like JavaScript-ish. I could easily think of something like that. I could easily think of some general procedural thing, and I could whip something up in about couple hours, if that. Start with a decent thing. We can actually put this into a different package. We've got an assembler. Keep everything nice and tidy. We can get our own type system, etc., etc. But now the question I have is more to do with how we're going to design this language and what is its purpose, what's its function, because then they'll probably define the usage here in this case. Because the purpose of this little thing was I want to have a language that's general purpose for the most part, and I can think of it in a procedural stance probably. Maybe it's a general purpose, but in what kind of sense? Let's not start another language yet under the influence. Well, that's the best time to start another language, isn't it? It worked out great the last time. Look, but the thing is that this is the case. Now, I'm working the opposite way this time. Like first time, I actually started in the parser. I went to tokenize, and that's the thing I was doing drunk. I went to the parser, then doing all that way and doing that from like top down. This is bottom up now in this case, where I'm starting with the assembler and working my way up. Because I'm trying to design it around the assembly language. Now I can see what the instructions have, but they're also very basic. Now, actually, I don't know what the dropping instruction is, in fact. What is drop? And select. Drop simply supplies instructions, simply throws away a single operand. Select instruction selects one of its first two operands based on whether the third operand is 0 or not. So that second operand is technically a Boolean, and you're not just a Boolean, but it's a Boolean for an index. So 0, I guess, is 0th index, 1 is one index. Or is it the other way around? I don't know. That's completely awful documentation. Yeah, so T is also, it sets and gets. So yeah, it's like it's like an expression in that's fine. It's probably just to save memory, really, isn't it? Okay, so we have load, which is the mem argument. And a mem argument takes in an offset and alignment. Interesting, actually. It takes an alignment argument. I would have not actually... it makes sense, to be honest with you, but I would have never actually have thought that. Because you can either load, because it has, what, integer type, and is that function? Oh, it's float type, yeah, float type, so I'm confused then. So you can load an integer or a float, or you can load the 8, load 8 of that thing, load the 32. Okay. And the other memory instructions you have is memory size and memory grow. So memory is access to load and store instructions for the different value types. They all take a memory intermediate memarg that contains a memory offset and the expected alignment, expressed as exponent of power of 2, expressed as the exponent of a power of 2. Wait, does that mean it's actually, if you want an alignment of 1, you put 0, and if you want an alignment of 2, you put 1, and if you want an alignment of 4, you put 2 in? Is that what that means? Expressed as the exponent of a power of 2. Because if that's the case, that's a good way of doing it, actually. That's just, that encodes it, reduces the size, of course, which is probably the benefit, because you're never going to need more than a byte. Even though it says XX up to a U32, and I'm like, okay. A static offset is added to the dynamic address operand, yielding a 32-bit effective address that is the 0-based index at which the memory is accessed. All values are read and written in little-endian order. Yeah, no. A trap results if any of the access memory bytes lies outside the address range implied by the memory's current size. So the memory size is what the current memory is, and the memory grow is when you need to grow it more. So effectively, you have one giant memory space for this heap, is what they've got. This got this stack and heap model. Makes sense. Keep them separate for this stack machine. Stack machine's calling instructions. It has its own stack. I guess that can be as large as it needs to be, but probably nothing big at all. And then the memory grow is this heap space. So you're now effectively having to make your own allocator, which is fine. I think for most of my applications, I would literally just say set it as a certain number and then just manually allocate it from it, which makes sense. And it says future versions of WebSounding might provide memory instructions with 64-bit address ranges. Fine, but for this time, I think 32 bits are absolutely fine within a web browser. I do not think I need more than 2 gigabytes, let alone 4 gigabytes of memory, especially for the things I want to try out. This is probably a long project. I wish I didn't start it sometimes, but oh well. Hey, I'm having fun. Ish. Okay. Control instructions. So what do the control instructions means? The NOP, the no-op. The NOP instruction does nothing. Good. But that's probably used for timing purposes or just for padding stuff in general. The unreachable instruction causes an unconditional trap. Fine. I'd use that for assert, obviously. The block and loop and if instructions are structured instructions. They bracket nested sequences of instructions called blocks, terminated with or separated by end or else pseudo expressions. If the grammar prescribes they must be well nested. Oh yeah. That's fine. So branch instructions come in several flavors. So a block is, I'm guessing in this sense, just a label, like a basic block that you can jump to, and then yeah, it says here each structured control structure introduces an implicit label. Labels are targets for branch instructions that reference them with label indices. Unlike with other index labels, indexing of labels is relative by nesting depth. That is, label 0 refers to the innermost structured control structure enclosing the referring branch instruction, while increasing indices refer to those further out or farther out. Consequently, labels can only be referenced from within the associated structure control instruction.
This also implies that branches can only be directed outwards, breaking from the block of the instruction target. The exact effect depends on the control construct. In the case of a block or if, it is a forward jump, resuming execution after the end. In the case of a loop, it is a backwards jump to the beginning of the loop. So by the looks of it, okay. So effectively, this means you don't have... If I'm reading that correctly, and tell me if I'm wrong, this means you can't really have a normal go-to. So you couldn't have let's say you have two branches. Well, okay, I'll write it. This is not valid Odin code because Odin doesn't have go-to. But what I mean is you can't have label 1 go to label 1. By the looks of it, that's what they mean you cannot do. You would effectively... Yeah, you can't do that. Just by this look. If that sounds right, because I just use Odin semantics in that regards, because I've already discovered how well those semantics work, and you don't even need go to and stuff like that. You can just break and branch out of stuff. Call instruction invokes another function, consuming the necessary arguments from the stack and returning the result variables of the call. The call indirect instructions calls a function indirectly through an operand indexing into a table. Since tables may contain function elements of heterogeneous type func graph, the call is dynamically checked against the func table, indexed by the instructor's intermediate, and the call is aborted the trap if they don't match. So the call indirect instruction calls a function indirectly through an operand indexing to a table. Oh, okay, that makes sense. So what that means... So just to make that perfectly clear, what that means is instead of doing this, you could emit op code const i32 in this case, and then emit u32 of the func index assembler mul, but we want to create a mul 32. In fact, actually, let's make that. That was simple. How simple was that? We call that mul 32, and what we then do, instead of this, we emit call. No, we emit call indirect. And it's failed. It's not very good in compiling construction, but obviously that's what's going to happen. So we've... Oh, that's because... Oh, no, that should be correct. Is it the other way around? No. So that works. Mul 32 is there, so that all works. So what was the call indirect thing then? Have I done that wrong, or is it because I need it to be the opposite way around? So call indirect. And then it takes a type index. Is that what it takes? So if I do... Well, first off, let's look at the other instructions. It's i32 const is what I'm looking for. Yeah. So we do this is why it's really confusing, this assembly, because it's all over the place in my opinion. Okay, so then we need to take the func sig index, and now it's failing. What the... What? I don't get what was going wrong now. This should be correct. No? Like, that should be correct. Why is that not correct? What does the call indirect do? Okay. I don't understand what I'm doing wrong here. Like, seriously, I don't understand what's wrong. So what I've done here is I've got the signature index for the function, effectively, which I've got. I've then... Yeah. Oh, you... Wait, no, that's correct. Or is it because I need to actually have this up here? Because I'm just thinking about how it's being... Okay, I don't know how it works. Because a normal call... Let's just make sure that works first. And it does, yeah. So it wasn't... Yeah, so the hypotenuse stuff works fine. Okay, so that's absolutely fine. So I think I'm just getting too tired now, so I need to probably go to sleep. But that I'm thinking is not bad for a nice drunk evening, don't you think, guys? I was going to watch the last episode of this season's Better Call Saul, but now I thought I'd do some drunk coding. Thought that was a better idea, right? Did you enjoy that, guys? Because that was all right. I'm just looking at what the instructions do and I'm trying to figure out. So you've got you've got a branch, a conditional branch, and a table branch. Which okay, so you've got to go to an if and a table. Now, is this a switch statement? Is what I'm guessing. I'm guessing a branch table is an indirect branch through an operand in a label vector that is an immediate instruction or a default target if an operand is out of bounds. Yeah, so it's a switch. That's pretty damn simple. Yeah, it's a jump table. So you have jump, jump, conditional jump, jump table. Perfect, makes sense. Okay, so that's all hunky-dory, all fun. I think next time I do streaming, I'll do it on Twitch, and I won't do it on YouTube. I'll just upload to Twitch. But this was a kind of good fun thing, and this was actually a nice little fun assembler. Now, if I make this smaller so I can see it, the actual code... Whoops. We can get rid of all this crap. So the actual code for all of this big project is it's about 600 lines, nearly 700 lines. I think that's not bad for saying so 600 lines is just to create a proper assembler. And that's a pretty good thing, to be honest with you. In fact, I don't even need the print bytes. Like, that is... I'm pretty proud with that, actually, let's say the least. So, thank you all for watching. I think this made some sense to me, at least. What was going on.
haven't tried making any locals yet, but I could easily store expression here. But next, I think the plan of attack, at least, is to, I'm just trying to think of a worse way of putting it, is to probably go for a language, but we need to plan that out. We need to plan out how this language is going to look, how it's going to function, and what is its purpose, because its purpose is, I'm not sure how broad I want to be, because the plan is, I think it probably should just be general purpose and procedural, because my idea, at least, is to just have a little language that can call to the canvas. That's effectively its main purpose. It's calling to a canvas and a console, of course. You've got the canvas and the console, because you need those two really. You've got a console for debugging purposes, and you've got the canvas for, you may want three actually. You want three different outputs. You want the console, you want the canvas, and then you also want the, I think, you want your own little console as well, terminal, like something to output to. Because that makes a lot more sense to me, at least. Actually, one before I do is I'll just do my old trick. Yeah, my old trick is that. Sorry, it's just so I can actually get the correct formatting and not have to worry about crap like that. But yeah, everything is working as I expect. And then, yeah, I'll probably want WebGL then. Well, I don't know. So initially, I don't think I'll need WebGL. I just want a canvas. So basic canvas to create basic crap. Because look, so HTML canvas. Let's look at what a canvas actually supports at the end of the day. Like, you can text displays if your browser does not support HTML5 canvas. Perfect. It's like an old script tag, clearly. So you can actually set up the canvas, and you can get the canvas and get the context, which is 2D. So fine. And then you can fill the context like so. So you can say it's a fill style red, fill rectangle, so whatever. And then you can have something of that style context. Now this context, this context for this canvas is pretty much a push pop system as well. So if you override something, it changes the next state. It's kind of strange. Yeah, I already know it's strange by just looking at that basic example. It's a poorly written API. But if we can do that, and we can actually get access to that, and we can use the canvas, we can get pretty damn far with things. Again, all these, I hate these tutorials, but the documentation is a pain in the ass to read, so you can't actually get anywhere. Like, this is, like, okay, fill style, and then what the, so that's kind of one. So someone's asking, so can Odin interact with JavaScript stuff or trying to do the same thing? So the answer is, actually, this is a complicated answer, actually. So the short answer is someone did get Odin working with Emscripten about a few years ago, actually, about 2 years ago. And they got it working fine and compiling. I never tried that myself, but they got it working, so good on them. But this thing is actually going to be something slightly different. I wanted a simpler language. I'm going to want a simpler language which is designed specifically for WASM, so the WebAssembly, because I doubt there's going to be another competing WebAssembly language anytime soon. I know there was one originally. WebAssembly. What was the alternatives? There was an alternative originally before. Oh, because WASM wasn't the only contender at the time. It was asm.js, I remember. That was it, asm.js. And there was another one, I think it was the Salt one or something like that. Native Client, that was it, Native Client Salt. Yeah, close enough in my head. And they were the two approaches that they were originally going to do, but they died, didn't they? So what I'm doing at the moment, to be very, very clear, sorry, someone's coming in, I'm not even using LLVM. I have written my own assembler. This is my own assembler, which outputs valid, valid stuff to be doing. So, for instance, here was my little function I wrote to do a hypotenuse. So I created a function, gave it a name, gave it a signature type. So this is it takes in two parameters. Zeroth is a float, another was on a float. Results are a float. So it takes one, and you can only do one. Yeah, so someone was saying it was just as easy as passing the LLVM IR to an inscription. Yeah, I didn't think it would be complicated. I just haven't done it, and I don't really want to, because it's one of those things where, again, it's not designed around this as an idea, because clearly this has got different constraints to a different instruction set, like compared to what those languages were designed for. Like, this is weird. It's very weird, and you can probably take advantage of its weirdness as well and design the language around it, so you can take some cool stuff from it. Other things I was taking a look like was I was playing this hypotenuse function. You set this to know how many locals you've got, so you have to set how many there are to begin with, and there are no locals. It's old-fashioned defining the block at the top. You then, because it's vector technically, just a vector of locals. They call it a vector. Again, they've done the stupid name of the fucking vectors. It's an array. It's an array of stuff. But oh well. And then you're going to get the local get, which is the zeroth local, which is from here. So this is going to be 0, 1, and then locals will be 2, 3, 4, whatever. I'm going to get another local get, which is from here, and that'll be the right indices. So this is local get 0, and put these onto the stack, and then we're going to multiply them together, and as a new value. We get to put 2 more onto the stack and multiply them together. So now we've got this value and this value left. Then we're going to add them together. We're then going to do the square root of that value and then click end. So one thing I could do to be very sane is the absolute. Now theoretically, you want the absolute when you do the multiplication. But you don't do it because you're assuming real anyway, so make a difference, does it? We're not doing complex numbers. So yeah, that's fine, and that's all correct. So we could do a lot of this cool stuff in this language. Now, I'm trying to think this through, but I don't think this wasn't difficult, and then you write the end. Now, I was expecting to write return. Now, it fails, but you have to end the block rather than have a return. Now, you could probably... I'm going to try, just before I go, I need to sleep really, but I just want to, I'm quite enjoying this actually, even drunk, is I wanted a conditional branch and see how does the conditional branch work. No, I don't need a conditional branch, I just need an if. So if block type instruction, else instruction. Yeah, I don't understand what that means. Either an index or a value type. Yeah, let's just not bother. I'll figure this out later. I'm not thinking clearly enough, is what I'm trying to state. So, thank you all very much for tuning in, and I bid you all a very good night, and, well, good night.